Okay.
Okay.
Please welcome
Okay.
Prof. Tariq. Yeah.
All right. Okay. Thank you. Assalamualaikum warahmatullahi wabarakatuh, and very good afternoon and also good morning for Aslan. So first, I would like to thanks you are IUM for inviting me to share something very interesting and important for us. That is 5G. Whether it's the title of the webinar, we see the Boon and the Bane of 5G technology. First, I think Professor Emeritus Tan Sri Datuk Zulkifli Abdul Razak, Director of IUM. Also the Professor Hussein Islam also as a panelist, and Professor Teddy as a moderator, and also Professor Datuk Nobit. Okay, I think I would like to share here to see the topic, a very interesting topic, and I think the right time as what mentioned by the Tan Sri just now. We're looking into the boon and the ban of the 5G technology. We're talking the boon means that are very helpful and improve the quality of life. And we're talking about ban means that a cause of maybe continuous trouble and unhappiness. So in my topic that I'll be covering is more related to 5G evolution and the use cases. We can see that whether the use cases that we have that 5G can provide will be benefit to us, to our life and so on, and also to see what is the evolution from the previous generation. We started with 1G before, 2G, 3G, 4 now we have 4G, and then as we understand that coming soon, by end of this year, there will be a new service of the 5G. And second thing, people talk a lot about the 5G, meaning that they are worried about the 5G interval. So we want to understand whether is there any issue of the 5G that we will have, and so on. So with that, I think I would like to cover my presentations with the time given. Where three things that I want to be doing. First thing is to answer, is the 5G is an evolution or revolution? What happened from the 4G or the previous generation? And from there, we can see that what is the 5G use cases that maybe we can see we have already 4G, but with 5G, maybe there are new use cases can be used with the capability or the what you call the vision requirement set for 5G. And then the third one is very important for us to understand, is a 5G safe? Because people talking a lot, worry about radiation, worry about all these things. So we want to really understand from the academic point of view. Okay, with that, I think I start off with this mobile radio evolution and revolution. If you can see here, the first generation started back in 1980s. And during that time, basically just only for voice, we can only make a voice at analog system. So actually what revolutionized mobile communication is the cellular concept, the cellular system, where you can reuse the frequency and then frequency reuse and cell splitting. But during that time, we only want to have mobility in voice. So when we move to the second generation, which means in the 1990s, is the digital. With the digital, not only voice, we can also send messages. But as we know that at that time, the speed is low. Only at that time, we can say that 60 kilobit per second or 38 by using GPRS or H384 kilobit per second. But if you say now we have 2G service here, it's just like no service because we need to have speed. Then move further to year in 2000 is the 3G. This is where the broadband started. 2G, the requirement is at least 2 megabit, where you can access not only voice or messages, but also internet data with 2 megabit. But of course, we need more speed. More speed when you are accessing internet, you get it. So they evolve further. From 3G, we call it as 3.5G, HSPA plus, to improve further the speed from 2 to maybe 7 megabit, 14 megabit, and so on. So you come to the next stage in 2010, then where we require enhance further the broadband, where the broadband of 4G. 4G can support, theoretically, what ITU set for 4G requirement is 1 gigabit. Yes, a low mobility and 100 megabit for high mobility. High mobility means when you're traveling in the very fast range, 350 kilometers per hour, our connection to internet has to be 100 megabit. That is the requirement. With that, we can see now, with a broadband, where this is through mobile broadband, where you can have a speed where you can have all those other application can be used there. So one thing that I want to share here related in Malaysia, where we are talking about now government is looking into the gender to what you call programs. Now we are the MCMC, for example, in the process of asking the regulation to sunset 3G, meaning that by end of this year, all the 3G services will be sunset. And why that required? Because the spectrum used for 3G in 900 megahertz, in 2100 megahertz, if we can use for 4G, meaning that if you see here, it can provide better efficiency, better quality. So instead of if they are sunsetting by the end of this year to ensure that the quality or the broadband facility is be able to cover all with 4G, but again, we still need 2G because at the moment, there are some phone with feature phone. They don't support VoLTE, they call it, voice over IP, because 4G are using packet for voice, for VoLTE, but 2G, 3G, they are using circuit switch. Currently, maybe there are people using the circuit switch feature phone and without VoLTE. They need to fall back for the voice call. And also some of the M2M, machine to machine, is still required. That's why I think what there will be from 2G, 3G, and 4G now will be left next year. We'll be having 2G and also having 4G. So next thing, the question now is that when you move from 4G to 5G, what happened? You see that 5G will define new use cases that we will see later. So the question now to understand the difference, what are the capability of 5G that will be benefit people and so on. Okay, so there is a question mark there, and we move further. We can see here theoretically 4G in the ITU term they call it RMT advanced. It can have to support 1 gigabit, but you need resources, you need spectrum, you need 100 megahertz of bandwidth to be able to provide 1 gigabit for low mobility, which means when you're traveling fast train, for example in Europe or in Japan, 300 kilometers per hour, your speed connection to the net has to be 100 megabit. You mean the 4G is good enough already for broadband and so on. But when you move further to 5G, that means the speed, that requirement that set here has to be 10 times, at least 10 times, 10 to 10 times much higher. That's why you're talking about 10 gigabit. That's why one of the features in 5G is called enhanced mobile broadband. Okay, and that's one thing. But not only that, from horizontal it go to verticals now. You're looking into latency. In 4G, the latency reduced. When you're talking about 2G or 3G, the latency is very high because that's why you cannot do a voice over IP. You have to go through circuit switch. Data go to the packet. You move to 4G, since the latency reduced 30, 40 milliseconds, for example, we can do VoLTE, voice over IP. But with 5G, further on, they require the latency to be very low, 1 millisecond. That's one thing. Second thing, we are talking about IoT, massive machine type. This is why they set up the 3 triangle here. We have talking about, if I can show a bit more detail here, you can see EMBB, enhanced mobile broadband, from 1 gigabit to 10 gigabit. It's just like a wireless fiber. Okay, we have connected that. And then from there, you can have 8K, 4K, 8K. Then you can have a remote consultation. Second thing, when you move further with ultra reliable, low latency, we'll be able to have VR, AR, and you wear a Google, if you wear that using 4G, because of the delay is high, you get headache. But with 5G, the delay of 1 millisecond just like a real time. And other things that you are talking about industry automation. In the manufacturing, for example, you have many robots that you need to control with wire and all those. This 5G is more, and then also for digital healthcare, remote surgery, autonomous car is possible. That's why they are putting the latency has to be less than 1 millisecond. That's why they say ultra reliable, low latency. This is the requirement set by ITU. They should be 99.9999% reliable with the low latency. Another component in the 5G where I to set to the vision and requirement require is the massive machine type communication. Meaning that this is not revolution. We can say this evolution, because the only difference that the 5G can support 1 million devices per kilometer square compared to the 4G where only can be maybe 100,000 or devices per kilometer. These are the 3 triangles that are required, that set by ITU for the vision requirement, and 3GPP is the standard body members from all the vendors and manufacturers, standard body who do the specification to be standardized, and so on. Okay, I think with that, I would like to share what is really the latency. People to ask what is the latency means. I'm showing here the concept. We are looking into, this is the concept only. If we have like this, for example, this traffic here, you don't worry about you are being collide with the car and so on, because with the latency of 1 millisecond, it shouldn't happen. You can see this is the concept. If what 1 millisecond latency can do what with the 5G, and that's why we can have this. We can have the autonomous car. We can have the car, remote car, control car, and so on. And it's in terms of safety wise, it's very important. Okay, it doesn't collide because the sensors can detect with a very minimum distance. That's one thing. Second thing, when you're talking about latency of 1 millisecond, you're looking into here. The robot here, for example, if I'm saying that this robot, if you can see that it can very precisely move through the wire without touching the wire with 1 millisecond latency. But if a human being, we have a wire here, we try to move manually across the wire, for sure we will touch the wire, because the human latency where you need to compute and calculate is about 14 milliseconds. But with 5G latency, 1 millisecond, this will happen. And with this, it's possible to do the remote surgery. Where a doctor can be somewhere else, robot is operating with very precisely, okay, what is doctor is moving. There is where the concept of 1 millisecond that have in the 5G, where with 1 millisecond latency. Okay, now we want to see what is the comparison difference. When we're talking about 4G and 5G, 4G we can say just now maybe 1 gigabit speed, but 5G is up to 20 times more, 20 gigabit per second. Second, we can look at in terms of user experience in the cell. Maybe 4G you are talking about 10 megabit, but within the 5G, because of the better efficiency, better need, we can have 100 megabit improvement. And spectral efficiency, meaning that the resources that spectrum we have, say one channel, maybe you can support one user if you are talking about it. If you use 4G, 5G, that amount of spectrum available can support more than 3 users. That's why just now we saw that why we need to sunset 3G. We sunset 3G, move to 4G, because basically 4G, comparing to 3G, 4G much better efficiency than 4G. But we move further to 5G, 5G is better efficient than 4G in terms of utilizing the spectrum. And again, the speed, I mentioned about the fast train, traveling 300 km per hour that 4G can support. But 5G, it can go up to 500 km per hour. Latency, we already discussed just now. Why we need 1 millisecond latency, where they have new use cases, critical missions. And also, connection density can support 1 million devices per kilometer square. IoT with massive, and energy efficiency and array capacity per meter square, you can support more bits, more quality. So these are the things. And if you want to compare again for 4G to 5G, you're looking into just now we are describing about the faster rate from here, and then the second, high density, high device density, in terms of 4G and 5G support million of devices per kilometer square. Reduce latency, we can see that reduced by 1 millisecond, we can see some critical mission can be done. And also lower energy, meaning that I will explain later, in 5G, there are technology revolution where they're using free informing, massive MIMO, they call it. And again, another feature that 5G have there, for example, you have a tower there, then there will be a backhaul connected by the fiber, where the fiber carry the information to the tower. But with 5G, instead of just carry the information for it, we can slice it. We can have one for remote surgery, one slice for the knee, and so on. So this is the capability that 5G can do. And I can show you this very important technology revolution that happened in the 5G. Okay, they're using the massive MIMO, what you call it as a smart antenna. You see that in 4G, normally you have a tower. When you transmit the tower, they cover the whole cell, or even the satellites. Like you have a water in your bottle, where you pour, it will spread out. So what the user experience will obtain is only small portion of what being transmitted. The rest is a waste, where we are talking about that. But with 5G, massive MIMO, they can have beamforming. Beamforming means every user have different beam to that. So that means there is focus to this, just like a spotlight. Every user have different that you can optimize further the spectrum, reduce the interference and so on. And this 5G also they're using antenna array, because in 5G the frequency also one component they're using mid band, and also the higher band the antenna size is smaller. It's capable to do that. The concept here you can see here, the beam is moving like that following the user. Maybe I can show one example here. That the trial been done back a few years back by the Harrison. Here, you can see this is a concept of the beamforming that 5G capable that cannot be done by other generation before. So as the vehicle move, this is the 5G base station. They have this smart antenna here by multi-beam, where the beam can focus, if you see to the car here, when say the beam, you can see the beam moving. This beam is following the user, the vehicle, and you can see that. So this is the concept that what 5G capability. This is, we can say that is revolution. That is where the beamforming is capable within this generation. Okay, in terms of spectrum, of course, in the 2G, 3G, or even 4G, the band is only lower band and a mid band. And but in the 5G is where they are using also millimeter wave. That's why people worry now where small cell, the base station close to the user, because with millimeter wave, the loss is high, only cover 200 or 300 meter per cell. You need to have a number of base station to cover that. But 3.5 is another band, new band, within not far from what the 4G band have. We mean the coverage. And if you have the beamforming that I've showed just now, the efficiency is much better. You are focusing the energy to the user. You're not wasting the energy at all. And then for lower band to cater for IoT, massive machine type communication, unique coverage. 700, this means that it can cover very large area, can penetrate into the building and so on. So these are the spectrum that been used in the 5G, the requirement. Okay, I think that's on the evolution and revolution side. You can see how we're moving from 2G, 3G, 4G, all talking about broadband, enhance further the speed. But when you move further to the 5G, not only enhance the speed only, but also become vertical, meaning that with low latency, ultra reliable, new use cases is possible. With massive IoT, you can have agriculture can come in, digital healthcare can come in. So I give you an example here to apply to three things here. EMBB, they mean enhanced broadband, ultra reliable, low latency, and also massive multi-type communication. If you have a building here, the tower is connected to the fiber. As you know that in Janela, they are talking about 7.5 million premises connected to fiber, either to a house or to the towers by end of next year. Okay, by the full scale of the Janela will be at least, we're talking about 9 million premises. So which means the fiber will be, say, here connected to the, instead of bringing the fiber to the home, the fiber can go to the tower, and then the last mile, or from here they call fixed wireless access, you can use wireless fiber. You can use 5G to connect to the building, because when you connect to the building, meaning that just like a wireless fiber. You can see also inside the building, if this is the clinic, okay, you can do a remote consultation. You can have a scanning here, X-ray, but this need to be sent to maybe the specialist, the water somewhere else in the city. But they can, as if you can have the real time, send the data in the real time with this, and then doctor can give a diagnosis and so on. And the third one, you see remote surgery. It's possible. I will show you later the examples of that. And this is autonomous car. And another thing where 5G is possible is the what you call hologram. As you see here, hologram meaning that if even we are PDPR, study from home or work from home, but with a hologram available as if that person are in front of us. Okay, and this is just an example is possible. And with massive machine type communication, we have just example smart building and other media of sensors connected around us. So first I will give an example of the EMBB, and HAMRO. Here is what I mentioned just now. For example, if you want to have the fiber to be connected to all the premises around here, of course, all the fiber has to be laid out here. But if you use the 5G, because it's just like a wireless fiber, it connected to the tower from the tower to all the places can go through wireless. And you can see that the distance 1 kilometer or 2 kilometer, the cost is the same, comparing to the physical cable like fiber being connected. And maybe you have an area here where they are sparsely populated. To bring the fiber to those locations will be very costly. But through wireless fiber with 5G can support, that is possible. Another example is, for example, in the stadium. When normal case 4G is enough, the capacity, the quality is enough. Then when it's an event over there, when hundreds of thousands people there, then okay, 5G of course can support. You can have 5G locally here to support those examples. That is on the MDB. This is another example, use cases where this in Japan, where they're comparing 4G and 5G in terms of remote consultation. And these images will be sent. And you can see here. And you can see here that, for example, if you use 4G with the speed that available here, this is where we are talking about the image of the being sent. When you send here, you need a very large. It's a large data that be sent. You keep on loading. But if you have 5G, will be smoothly like that. All right, that's very important. The doctor, because they don't expect, as if you are in the same location, you are connected to that. So this is one example. And one another important what I want to share here is the remote surgery, for example, with the 1 millisecond latency. You can see here, I don't know, maybe consider aware that this is a laparoscopy. Laparoscopy means we don't do open operation. We have a hole there, then the robot in, and the doctor is controlling the joystick. But the doctor is just next door, where these are connected through cables to the robot, where the robot is using that. And I give this example, for example, maybe the specialist is in hospital Putrajaya, but the patient is in Miri, hospital Miri. But we can do remotely the operation like similar to what the laparoscopy can do. Why we can do that? I showed just now that with the robot you can control very precisely on that. And maybe I can explain here. The next slide here, you're showing that here is the joystick where doctor controlling here. There is a patient here, robot is controlling, but these are connected through cable because you need to have very reliable, 100% reliable, 99.99% reliable and low latency. Okay, that's happened. But with 5G, if this 5G is there, you don't require the cable. That's why I'm saying that one in the Putrajaya and the specialist in Putrajaya, and then it's in the what you call Miri, then you can do the similar thing. This is just an example what the possible with 5G with the low latency. And this is the one is connected ambulance. For example, there is emergency. Ambulance is equipped with all those facilities, and there is a 5G connected to both sides. Along the way, where the emergency happen, the patient, all the information can be taken and sent to the hospital. And when the patient arrives at the hospital, it's already ready, already done, all the data is available for the diagnosis and so on. So this is an example of the digital healthcare that 5G can provide. Okay, this is another application that they use for platooning. Platooning means you have a truck in front, but at the back there is no driver. They are following with and connected. With 5G, ultra reliable, low latency, this is possible. Okay, on the automotive side. And I already described just now, we are talking about all the car are connected and all this, and it's possible. That's why the what you call driverless car is possible. No driver. Okay, and also remotely, I can share here that before I think the last few years, I visited Mobile World Congress in Barcelona, and here I have a trial at one booth from Ericsson, showing that if I drive in the Barcelona, the car vehicle is in Sweden. So we can see that with the connected both sides with 5G, you see when I move the steering, the car also moving. This is how the application of the 5G is done. So in the manufacturing, again, you can see here, in the manufacturing, we can see that this can happen. You have a robot doing all the assembling and all those things, but all those robots are all connected by cables. has to be very reliable. But with 5G, those in the factory or the manufacturing side, all can be replaced by wireless through the 5G, seen of the ultra reliable low latency capability of the 5G. Okay, this is the example here. And then the next one in the construction, you can see that you can remotely control the excavator. You can be somewhere else, okay, and control the excavator remotely. And I have tried it when I visited Japan. This one remotely control the excavator here. You can see here. Okay, so this is the real thing that happened that they are when they do the trial there, and it's happened in China. Pelombong guna teknologi 5G itu kerja dari rumah. We can do a work from home. From here, you can see here. This is what happened. We see that the nobody there controlling the excavator, in the controlling the road, all are driverless, but all are controlled in the center, the control center here, okay, in the construction site. So those are the examples that possibility of the 5G can do with this ultra reliable low latency. And the final one, you're talking about massive machine type communication. You imagine, now we have world population about 6-7 billion. There are pretty 40 billion of connected devices, meaning that more than 2/3 of the things surrounding us are all connected. You're talking about everything is connected. Okay, and we need massive. This is where, just give an example, TMB. They are now upgrading, changing the meters in our home. Instead of people come and read the meter, they are talking about they may by sending the IoT thing, the sensors of the meter, and then they update the data center can get information. This is only that one thing. But you're looking future, everything is connected. We're talking about massive machine type communication. So these are the three things important that 5G provide. EMBB, we're talking about enhanced evolution, that one. We're looking into ultra level, is this the revolution? And then again, massive machine type is already continuation of what the things being connected, but it's talking about massive. Okay, that is what we can see the good things of what the 5G can provide. That we can see here, where the 5G basically can what you call give us the more convenience in terms of what we call it that helpful and improve our quality of life. Now we want to see a cause of continuous trouble. People keep worrying, is a 5G safe? This is, we need to understand. The issue now is people worry about radiation. You know, radiation, you know, we have to understand what is the radiation and what is the radiation from 5G base station, even 4G and so on happen. Here I want to show you the electromagnetic spectrum. And you can see the electromagnetic spectrum cover very low frequency up to the light frequency, even X-ray, gamma ray. Okay, and you can see that 2G, 3G, 4G are all within this range. Radio frequency is between 3 kilohertz to 300 gigahertz with this range. Above that, we have the infrared, visible light, and then we have beyond that infrared, also ultraviolet, and also X-ray and gamma ray. And all those things you see here, they are being categorized into two, where people have to know that non-ionizing. Maybe if you can see here, the radio frequency, including 5G here, energy here, important here is the energy. Electron volts, where only 1,000 times less than even the light frequency. Okay, so you can see here, it's even the sun. The sun is the light, where have 1,000 times much higher compared to the radio frequency here. But it's still safe. But you can still feel the radiation. You can feel the heat. Okay, but the dangerous of that is when we move into the non-ionizing side, which is ultraviolet. That's why when you expose to the sun, some location, you can have skin cancer, because these are under ultraviolet is under the ionizing side. Even X-ray, you have to do X-ray. You go to the hospital, meet a doctor, you complain, then doctor say you need to do X-ray. Of course, if you have to do X-ray, otherwise they cannot diagnose you. But when you do the X-ray, even they put a very low dose, and your body can recover. Similar to what happened when you are exposed to the sun, you get sweat. This is how your body reacts. But there is that's why you cannot do a very frequent. But if you see here, a mother, pregnant mother cannot do X-ray because the baby is very small. It cannot recover back. Okay, so that's why it provident for the pregnant woman to do the X-ray. But they can do ultrasound. Why ultrasound can? Because ultrasound is the lower frequency. Energy is less. Okay, so that's why there are these two signs is important. So we can say that even the 2G or 2G, 3 or 4G much lower than if you are worried about this radiation, you are worried about what you call the sunlight. Even you are in the sun, you can see it's 1,000 times much higher. So why that is important, you can see here. To differentiate between non-ionic radiation and ionic radiation. Here we can see our cell, when we have electron and nucleus. When we are exposed to the radiation of non-ionizing, what happens is that you cause vibration. And this vibration, the energy is not enough to cause this to be freed from that. Then why it causes only heating effect. Similar to what happened when you put your food into the microwave oven. Frequency of microwave oven is same as the frequency of your Wi-Fi. That's 2.4 gigahertz unlicensed band, but it's very high, 600 watt. That why can cook your food, can heat your food. But if you are talking about ionizing radiation, when you are exposed to the radiation, even though say what happened here, it can cause the ionize to happen. This is what worry. This is what you can cause cancer. Okay, so that's it. So if you compare back, when you are talking about 5G, for example, is this here, 2G here, and then comparing with the other spectrum like even visible light, yeah, and also this is non-ionizing side. But we're talking about higher band, yes, this is the. But another thing that World Health Organization (WHO) have confirmed that there is not confirmed any existence or health consequence from exposure to the low level of electromagnetic before. This is what from WHO. The only issue, things that happen when we talking about tissue heating. And then, so I want to show you. This is just to share again what is happening surrounding us. TV, usually, the only electromagnetic wave that you can see with your eyes is light. Like you see the TV, the light coming out. But the rest that you see surrounded you, there are many waves from the towers, from the cell phone, from the Wi-Fi, and so on. All I think all around you, but you cannot see it. And that's why you can see the signal on your handphone, the level, and so on. And also, I want to share here the study made in US, where they are started in before the phone had been used. Where as you move further, where the people start using many number of mobile phone increases exponentially, and the brain cancer that happens doesn't correlate with the what you call the usage of the handphone. And again, we want to show here again what the measurement being done locally here, where we measure what is the level of the radiation from the towers. We have the rooftop there, we have on the towers in one of the village, we have on the buildings and so on. And this where the people moving near the surau. These are the probe or the equipment being used. When you measure, we can see that the level we are obtaining from those base stations are very low, less than 10% from what been set by the international standard. They call it IGNIM. IGNIM means International Commission on Non-Ionizing Radiation. This is an international standard recognized by WHO. If you reach 100%, it's still safe. This is non-ionized, and this is to prevent adverse effect. Adverse effect means when you been burned by your hand, you feel pain. There is an adverse effect. But here you can see even less than 10% that from different environment. Okay, so this is what the thing that happened, because we can see when signal radiated out, it was spread out. Why you obtain a small portion of that, and then so this is just to confirm that basically no issue that we can have to be worried about what the happen when 5G is coming. Okay, and then I think the next one maybe I want to share the implementation. If you want to implement that transformation, just now about you will be 5G is coming, and then what happened that or today, and see we can see that in the Jendela, for example, phase 1, that is by end of next year. They are talking about having fiber to every premises, 7.5 million fiber, and then they're expecting to get 35 megabit per second of broadband. Now we see complaints, a lot of complaints of the digital divide in the with work from home, with study, PDPR, and all those things. Internet, because internet here considered has third utility. It's similar to the electricity, similar to water. But if, for example, I have electricity is you have a water, you have a pipe going to your house. But if you open the pipe, the water is very slow. Of course, you are not confident. You want to have certain speed, certain level of the. So it becomes third utility now. And then we are looking into the next general phase for 96.9% of 4G coverage, meaning that by sunsetting 3G this year, you can utilize the spectrum more efficient. Then you can have more spectrum quality wise, not only coverage. We are talking about the quality, and then and when you want to implement 5G, for example, 5G don't require, for example, here 4G and 5G can work together. Even you have 96.9% of the coverage, but you want to have a 5G in the hospital or the school, you can have. They can use the existing core network of the 4G. Okay, you can see that. And later, of course, when they want to upgrade further, they can have their standalone. It's what we call non-standalone and standalone possible. This is the first phase of implementing of 5G, where you can work together with 4G using the. And again, since we are talking about the fiber to be 7.5 million premises, we are looking into 5G need fiber. Without fiber, you cannot implement 5G because of the broadband and so on. And see, and again, from there, I think I can make a conclusion here. Since, okay, in concluding remark, we can answer the question that we are raised just now. First, we're talking about, is a 5G an evolution or revolution? Then, yes, it's an evolution, meaning that evolution means enhance further what the existing system has. It can work together with the 4G, can use the existing infrastructure at 4G to start first phase or toward the 5G. And second thing is there also revolution. You can see that 1G to 2G we can consider is the revolution. But you move to 2G, 3G, 4G, that is evolution. You are talking about speed. You're talking about accessing internet at a higher speed. Okay, and then the evolution and that happened there. When you're talking about next level 4G to 5G, is right. Is evolution mean enhance further, where you can do remote consultation, you can have 4K. Even you want to see the doctor, not necessary to travel and go and meet the doctor. You can see through the network as if the doctor is in front of you. He can diagnose you. You can see what the condition as if the doctor are in front of that. Okay, and also there are some critical mission requirement like remote surgery I just mentioned just now in the factory, in other places. So it becomes then, and then that's why we're talking about the use cases. It become not only B2C, B2B. B2C means from business to consumer, per customer. You are not talking about only your device, your handphone connected, but you are talking about new verticals. Agriculture come in with message type communication. New industry is possible, and all those things. It create new economy. It create that thing. And then the last one we're talking about the ban, whether the 5G is safe. I think just now I already showed that. No proof. We have done that. And also we can see that if we worry about this radiation with radio frequency, because radio frequency cover 3 kilohertz up to 300 gigahertz. The 5G only using 700, 3.5 gigahertz, 28, far below the maximum range of the radio frequency. Even you are at 300 megahertz, you are much safer still, because beyond that is the infrared. You are talking about what you call the light, visible light. The sun is the visible light. If you are worried about this 5G, the signal radiation to get cause on it, you don't go to the sun, because the sun is 1,000 times much higher energy. The important is the energy, whether it can break the cell. But even the sun is still safe because it's categorized under non-ionizing, and where it can cause vibration, it can cause heating effect, thermal effect. Where the ignite come in just to set the minimum internet effect. Even that, when we measure from the base station, it's only less than 10% of what being measured. Okay, and when you come to 5G, even better, because 5G using the smart antenna beamforming, the energy only focus to you. When you're talking about focus to you, like a spotlight, you don't require high power to be transmitted to the person. just enough. And then as you move away, you will follow. Otherwise, in the 2G, 3G, or 4G, meaning that you have to, meaning blast the whole area. But here you are focusing to every user, and you can, that is even it's safer in terms of that. Okay, so I think there is no issue that talking about whether it's safe or not, because if you are comparing with what as the in terms of energy level, in terms of understanding what are the spectrum, what are the radio frequency, what are the radiation, and so on. Okay, I think with that, that's why I think Mr. Chairman, the moderator, Prof. Eddie, that I would like to share here. Okay, thank you very much.
Yeah.